Hello students, welcome to today's class. I am Bernisha, lecturer from EMULSION College of Pharmacy. Today we are going to discuss about pharmaceutical emulsion from pharmaceutics. In the last video, we have learned about the introduction of emulsions along with the type of emulsions. Today we will focus on what are the preparation methods used to prepare a stable emulsions and how to prepare a stable emulsions and the identification techniques which is used to identify the type of emulsions, whether the emulsion is oil in water type or water in oil types along with their applications. Okay students, let's get into the slides. First, let's see what is emulsion. Emulsion is a biphasic liquid dosage form which consists of two incompletely immiscible liquids in which one is dispersed as a finite globules in another phase. Here mainly the oil and waters are naturally immiscible. Here the special methods of preparations are required to form a stable emulsions. We have already known that emulsion is a biphasic liquid dosage form which consists of two incompletely immiscible liquids. That is, they won't mix with each other without any proper preparation method or without adding any emulsifying agent. So, we already know that oil in water are naturally immiscible. So, we have to use some special methods to prepare this stable emulsions. There are four types of methods which is used in the preparation of stable emulsions. They are dry gum method, wet gum method, bottle method, in situ soap methods. There are four methods. They are dry gum method, wet gum method, bottle method, in situ soap method. These are the four methods which is commonly used to prepare the stable emulsions. Okay, next we are going to see about dry gum method. So dry gum method which is used to prepare stable emulsions. Mainly this dry gum method consists of a formula with a ratio of 4:2:1. We know that we have to prepare two phases, that is continuous phase and a dispersed phase with the two immiscible liquids, which means water and an oil. So in this dry gum method there is a ratio which is 4:2:1 formula. That means 4 parts of oil and 2 parts of water with 1 part of gum. So these are the volumes which should be taken correctly, which is 4 parts of oil, 2 parts of water, then 1 part of gum. In this name itself, we can identify it's a dry gum method. So we have to add the water at last. First, we have to titrate both the oil and the gum. So let's see the procedure. First, in this, we have to take our oil phase and titrate it with gum by using the mortar and pestle. For the titration process, we have to add a little amount of water to form the primary emulsions. When the oil is first titrated with the gum, there will then small amount of water will be added to it to form a primary emulsions. We have to titrate fully with the mortar and pestle. When then we can identify when the emulsion is prepared, when we have to know the primary emulsion is ready. When the titration is continued, then we can hear a clicking sound. There will be a clicking sound. When the clicking sound is here, a thick white cream will be formed. We actually, because we are using oil and gum, so when we are titrating the oil and gum, after hearing the clicking sound, we can see there will be a thick white cream. Once that primary emulsion is formed, that thick white cream is the primary emulsion. Once that primary emulsion is formed, the remaining quantity of water, we have to add the remaining quantity of water to that thick cream. But we have to add little by little and titrate it continuously so that we will get a proper uniformly distributed emulsion. This is the procedure for preparing the dry gum method. In dry gum method, first we have to titrate oil with the gum. After that, after getting the primary emulsion, we have to add the remaining quantity of water slowly to that of the emulsion to get a stable, uniformly distributed emulsions. So dry gum method means first we have to add oil and gum, then at last we have to add the water. Second method is wet gum method. This method also consists of that 4:2:1 ratio, that is 4 parts of oil, 2 parts of water and 1 part of gum. Here in this procedure, the name itself implies it's a wet gum method. So first we have to take the water and the gum. So the gum and the gum is triturated with water. In dry gum method, the gum is triturated with oil phase. Here the gum is triturated with water. Wet gum method means first itself we have to add the water. So, while triturating, we will get a mucilage. After that, we have to add small quantity of oil in that, so that during triturations, we will get the primary emulsion. We have already known that primary emulsion means there will be a preparation, there will be a formation of thick white cream. When the thick white cream is formed by after hearing the clicking sound, we have to add the excess remaining quantity of water, so that we can easily make up the final emulsion. First, in the wet gum method, we have to titrate we have to titrate the gum with the water. First, we have to take the gum, then the water will be added to that gum, and we have to titrate it using the mortar and pestle. Then at last it will form a mucilage. When the mucilage is formed, we have to add some oil with that to form a thick white cream. The thick white cream denotes the primary formation of primary emulsions. Once the primary emulsion has been formed, we have to add the remaining quantity of water to make up the final emulsions. So we have to add the water, which is 2 parts of water and 4 parts of oil and 1 part of gum to prepare a stable emulsions. Okay, this is wet gum method. Next we are going to bottle method. Bottle method is another type of preparing the stable emulsion. Here we are going to prepare an emulsion containing volatile and non-viscous oils. When emulsion contains a volatile oils or a non-viscous oils, we will choose this bottle method. This method is also known as Pope's bottle methods. We can use both the wet gum and dry gum method. We know dry gum method, first we have to add the gum and oil. Next, in the wet gum method, first we have to titrate both the gum and water. So we can use both the dry gum and wet gum method in the bottle method. When the volatile oils have the low viscosity, which is compared to that of the fixed oils. So when the fixed oil is there, we can directly use as the dry gum or wet gum method. But when the oil's viscosity is very low, or it is when there is a volatile oils, we have to choose this bottle method, because they requires a large quantity of gum for emulsifications. When we choose as the dry gum or wet gum method directly, we requires a large amount of gum. As we know that we have to choose it based on the 4:2:1 ratio. So only one part of gum should be added to prepare a stable emulsions. But when the volatile oils are used for the preparation of emulsions, it requires large amount of gum for emulsification. So only we have to directly comes with the bottle method. Here in this method, whether we are going to if you are going to prepare an oil in water type emulsion, first we are taking the oil, then we have to mix shake and thoroughly using the calculated amount of gum. So first if we are taking the oil means, then we have to mix the oil and gum in the bottle, and we have to shake it thoroughly. Once it has emulsified completely, next we have to add the water. Likewise, when we are preparing water in oil emulsion, so first we have to add water with the gum. Next, after shaking it vigorously, after we have completely emulsified, we have to add the second liquid. Once all the liquids are added completely, we have to shake it vigorously to form the primary emulsions. Once all the primary emulsion is prepared correctly, we have to add remaining portions of water in a small portions and with constant agitation to form the final volume of emulsions. Once the primary emulsion is done, we have to add water in a small portions with the constant agitations, and we have to produce as the final volume. This is the bottle method. Usually the small bottle method is used for the preparation of emulsion containing the volatile oils or the non-viscous oils. Let's see the procedure for the bottle method. As we know that it is an preparation of emulsion containing the volatile oils or the oil with low viscosity. First, we have to take the compressed oil in a dry bottle and shake it vigorously. Once it has completely emulsified, we have to add the water which is equal to the volume of oil we have taken before. So when all the portions have added, we have to shake it vigorously until it forms a primary emulsions. Once all the primary emulsion is formed, the remaining quantity of water is added to make the final emulsions. So once the primary emulsion is done, we have to add the remaining quantity of water to it to make up the final emulsion. This is the simple method of the preparation of um, simple method of preparation of the stable emulsion by using the bottle method. First is compress oil in a dry bottle. We have to shake it vigorously. Then we have to add the second medium like water, which is equal to the volume of the oil. Next, after all the portion is added, we have to shake it vigorously to form a primary emulsion. Once the primary emulsion is formed, we have to add it to make up the final emulsion. Next method is in situ soak method. In situ soak method is also known as nascent soak method. It is also known as the nascent soak method. The in situ soak method is a technique which is used to prepare the emulsions when both the phases, when the oil phase and the aqueous phase are joined together or mixed together due to a chemical reactions. It forms a soap-like emulsifying agent, because we know that in situ soak method means when the oil phase and the aqueous phase are joined together, thereby a chemical reactions. Because of that chemical reactions, there will be the formation of an soap like emulsifying agent. There are two types of in situ soak method. One is calcium soak method and another one is sodium soak method or potassium soak method. First is calcium soak method. Usually, this method is used to prepare the water in oil type emulsions. What emulsions? Water in oil type emulsion is mainly uses this calcium soap method. If an oil phase containing the fatty acids and an aqueous phase containing the calcium hydroxide, when both of the phases are going to mix together, it forms the calcium soap. That calcium soaps itself act as an emulsifying agent. So when the oil phase and the aqueous phase joins together, it forms a soap. That soap itself acts as the emulsifying agent. For example, if a lime water is mixed with oleic acid, it forms a calcium soap. Next is sodium or potassium soap method. It is mainly used to prepare or produces the oil in water type emulsions. Mainly the fatty acids like sodium hydroxide, fatty acid reacts with the sodium hydroxide or potassium hydroxide. It forms a sodium or potassium soaps. So it helps to produce the oil in water type emulsions. So in situ soap method means when both of the two phases reacts with each other, it forms a soap which is act as an emulsifying agent. So these are the four methods which is used in the preparation of stable emulsion. First method is dry gum method, and the next method is wet gum method. Next is bottle method, and the last one is in situ soap method. These are the four methods which is used to prepare a stable emulsion or a type of emulsion, whether it may be an oil in water type emulsion or water in oil type emulsions. Mainly the in situ soap methods, we can easily produce the which type of emulsions we have required to form here. So these are the methods which we are used to prepare the stable emulsions. Next, we are going to discuss about the identification test for emulsions. The identification of the type of emulsion is a very crucial step in the pharmaceutical formulations. Mainly, it involves the it is a crucial step in the formulation and also in evaluations, because most of the physical properties, their stability, their therapeutic effectiveness, and the route of administration are all depends on whether the emulsion is oil in water type or water in oil type. Mainly these all the emulsions, both of the emulsions are appears macroscopically similar. So it is not possible to distinguish their types by simple visual observations. With our visual observations, we cannot distinguish whether it is an oil in water type emulsion or water in oil type emulsions. So there are various identification tests which is carried out externally to determine the external phase of the emulsions. By knowing that external phase, we can easily identifies the type of emulsion, because because the test we are used in the identification of emulsion based on the principle that the continuous phase governs the physical and electrical properties of the systems. So there are certain tests which is used for the identification of emulsions. Moreover, we have used 5 identification tests to identify the types of emulsions. The commonly used tests are dilution test, dissolubility test, conductivity test, cobalt chloride test, and fluorescence test. These are the 5 tests we are used in the identification of emulsion. So the first one is dilution test. Dilution test is nothing but, before getting into the detailed study, let's see why this identification tests are important. Why this identification tests are essential? Because to ensure the correct formulation, this identification tests are important. Next, to predict the shelf life and stability. In order to predict the shelf life and stability, we have to identify the types of emulsions, and also to identify the storage and packing conditions, and also to achieve the proper therapeutic actions. These are some of the reasons why we should identify the types of emulsion is very important. So the first test is dilution test. In this test, the emulsion is diluted either with oil or water. In this the emulsion will be diluted with either oil or with water. If the once we are adding an oil or water, if the emulsion is oil in water type emulsions, if you are let's see discuss it with the help of picture. In the first picture, the emulsion is oil in water type emulsions. We are adding water with it first. First, we are adding water to it. Actually, it is an oil in water emulsion. We know that oil will be the dispersed phase and the water will be the dispersion medium. But once if the emulsion is diluted with water, it will be of same. The oil will be the dispersed phase and the water will be the dispersion medium, and both the phases will be stable. There will be the no changes in the phase. But once it is diluted with oil, there will be the change in the phase, because it will changes to water in oil emulsion, because we can easily identify that the emulsion will break as oil and water will not miscible with each other. We can easily identify there will be the 2 different phases. The water will be in large amount and the oil will be in small amount. Within that, we can easily identify the dispersion medium. With the help of the dispersion medium, we can easily identify which type of emulsion is this. So if we go into the next picture, we can see that first we are taking water in oil emulsion. Next we have to dilute it with oil. Oil, if we are diluting it with oil, we can easily identify that there will be no changes in the phase. It will be same as that of water in oil emulsion, and it will be conformly, it is stable. So next, if we are diluting it with water, so if you are dilating it with water, we can easily see that the emulsion will break us in water, and the water will not visible with that of the oil phase, and there will be the separation of two phases, and we can see that the oil phase will be in large amount and the water is in small amount. Within that, we can easily identify that which is the continuous phase. Within that, we can identify which type of emulsion is this emulsion. And we know that in oil and water emulsion can easily be diluted with aqueous solvent, whereas water in oil emulsion can be easily diluted only with oily liquid. So, what will be the continuous phase? That continuous phase liquid should be added to it to get proper dilution. So, based on that continuous phase, we can easily identify which will be the type of emulsions, whether it is the oil in water emulsion or water in oil emulsion. The next test is conductivity test. We have known already that water is the good conductor of electricity. Everyone know that water conducts the electricity. So therefore, in case of oil and water emulsions, let's see it with the help of picture. It's a Here in that picture we are taking water in a beaker, and it contains the two electrodes. One is the cathode and another one is the anode. So when the cathode and anode is joined with an electric bulb, when these both the electrodes are dipped into the water, we have to dip both the electrodes in the water, and we have to connect it with the electric current. We have to connect it with the electric current. We have to take both the beakers. One beaker contains water and another beaker contains oil. Here the first beaker contains water and the next beaker contains oil. So that the first beaker denotes oil in water emulsion and the second beaker denotes the water in oil emulsions. Two electrodes are joined together. Here the two electrodes were dipped inside the emulsions and it is connected to the power supply. Once the current get passes to it, the beaker which contains water as the continuous phase, the bulb will close, and if beaker which contains oil as the continuous phase, the bulb does not close. With this interpretations, we can easily identify which is the type of this emulsion belongs to. Which type is that emulsion? With the help of the continuous phase, we can know that water is the good conductor of electricity. So the beaker containing oil in water emulsions, while applying the electric current, the electric bulb will glows. But if the emulsion containing water in oil emulsion, so that the continuous phase is oil. So when the power supply is given to that the electrode, the bulb does not glows. The bulb does, with the help of that bulbs, we can use with the help of that bulb glows, we can easily identify which type of continuous phase is present in that beaker. With the presence of continuous phase, we can identify which type of emulsion is that. And the next is dye solubility test. Dye solubility test is another type of test. In this, two types of dyes we are using. First is water soluble dye and another one is the oil soluble dyes. We know that water soluble dye soluble in water and gives color, but the oil globules does not infuses the colors. But the oil soluble dyes only soluble in the oils, but the water does not get that color. So when we are seeing that picture itself, we know first picture denotes the oil in water emulsions. Oil in water emulsion means the water denotes that we know that the outer surface. We know that outer surface is the continuous phase. Outer surface is the continuous phase. In first test, in first we are using the water soluble dye. First we are using the water soluble dye. So for example, we are taking amaranth. First we are mixing the water soluble dye in that emulsion and taking a drop in the slide, and we have to watch it in the microscope. Once we have watched it, observed it in the microscope, if the continuous phase is red in color, if the continuous phase is red in color, it will denotes that it is oil in water emulsions. And if the globules appears colors, it denotes it is water in oil emulsion. So, with the help of the colors, for it is for water soluble dyes. If the outer surface have that red color, it will shows that it is oil in water emulsion. If the globules inside the globules, if the appears in red color, it shows that it is water in oil type emulsions. Next, we are using oil soluble dyes. For example, scarlet red or Sudan 3. We are using scarlet red. Commonly we will use scarlet red. When we are adding the scarlet red to that emulsion and observe it in the microscope, we can easily find that if the continuous phase appears red in color, we can easily find that it is oil in water emulsions, because we know that oil soluble dyes only soluble in what? Only soluble in that oil, only soluble in the oils. So if the outer appearance is colorless and the inner appearance is colored, we can easily found that it is oil in water emulsions. And if that outer appearance is colored and inner appearance is inner globules are colorless, we can easily found that it is oil in water type emulsions. Within this observation in the microscope, we can find out which type of emulsion is present here. Next is fluorescence test. Fluorescence test is a type of test in which we have used UV radiations. For that, if an emulsion has an exposure, sometimes we will use as the fixed oils, because the fixed oils have a capability of fluorescence. It has the capability to get fluorescence when it is exposed to the UV radiations. So, if you are taking an emulsion, if they are continuous phase, if its continuous phase gets fluorescence, if its continuous phase flows fluorescence means we know that outer continuous phase is oil. So, it will be at water in oil emulsion. If that in the next appearance, if there is the inside globules, so if that inside globules shows fluorescence, we can easily identify that the inside globules are oil. So it will be oil in water emulsions by seeing this images. So let's see this images. In the first image, it is oil in water emulsion. We can see that. um, the emulsions, the fixed oils shows fluorescence like spots. So it is oil in water emulsions. But in the second image, we can see that the continuous phase fully what which shows fluorescence. So we can see that the outer continuous phase is oil. So it is water in oil type emulsions. So which is based on the one principle that the oil shows fluorescence under UV exposure. Based on that, we will classify the type of emulsions. And the next test is cobalt chloride test. So, in this cobalt chloride test, for that first we have to take the filter papers. So, when the filter papers, first we have to soak that filter paper in the cobalt chloride solutions. We have to soak it in the cobalt chloride solution. After dried it and take that filter paper. When the filter paper is dipped in an emulsion and dried, we have to dip the one end of the filter paper in the emulsion and keep it dried. If that filter paper turns from blue to pink, so that it indicates that the emulsion is oil in water type emulsions. So that if the cobalt paper turns to pink, it denotes that emulsion is oil in water type emulsions. So we can easily find that taking the first image shows that we are soaking that filter paper in the cobalt chloride solution And here two tubes are taken. First tube contains water and oil type emulsion, and the next tube contains oil in water type emulsion. When we have dipped that cobalt chloride paper in the water in oil type emulsion, there will be no changes in the blue color. There will be no changes in the blue color. And when we dip the cobalt chloride papers in the oil in water type emulsion, we can see that the blue color changes to pink color. So the second type is oil in water type emulsion. So based on the pink color, we can easily identify the oil in water type emulsions. So these are the methods we can easily test, which is used to identify the type of emulsions. First test is dilution test. Next is conductivity test. Next is fluorescence test. Next is cobalt chloride test. Next, along with the dye test. So these are the tests which is used to identify the type of emulsions. Next, we are going to see about applications of emulsions. What are the applications? It's mainly for that emulsion. In this following session, we will discuss about the various application of emulsions under different categories. So first, we are going to discuss about the pharmaceutical applications. Pharmaceutical application means why we are using this emulsion in the pharmaceutical industries. First, it is used to mask the unpleasant taste of oils such as cod liver oils. We know that cod liver oils exhibits the unpleasant taste or the bitter taste. So, emulsion is mainly used to mask the unpleasant taste. Next, it enhances the bioavailability of poorly soluble drugs. As we know that both the immiscible liquids can also be formulated into emulsions. So, if the drugs which has poor bioavailability can also be formulated into emulsions, which enhances the bioavailability. Next, we can versatility. So, it can be formulated into oral emulsions, creams, ointments, and lotions. So, it can be easily formulated into different types. So, for emulsions is applied is you emulsion application in the pharmaceutical side is very important. And next is used in the parental nutrition, mainly because of which it has a vast side on the parental nutrition. So in pharmaceutical application, it is mainly used as the parental nutrition or pant emulsions. The examples for this pharmaceutical application includes liquid paraffin emulsion, propofol injections, like liquid paraffin, vanishing creams, cold creams, like many emulsions. So it will be of many types. So these are some of the pharmaceutical applications of emulsions. And the next one is cosmetic applications. Moreover, from pharmaceutical side, we know that emulsion has a vast side or very important role in the cosmetic side also, because it is widely used to prepare creams, lotion, and sunscreens. We know nowadays sunscreen is very important for our day-to-day life. So this emulsion is playing a very important role in the formulation of lotions, sunscreens, and creams. Next is to provide moisturizing and protective effect of skin. We have already studied that it is used for the preparation of vanishing creams, cold creams, which gives us the moisturizing effect to the skin, and it also protects the skin from UV radiations like that. Next is to improve texture and spreadability and appearance. Mainly nowadays, the drugs are formulated into the emulsions or lotions and creams because it improves the texture. Also, it enhances spreadability, and it enhances the spreadability. That's why it enhances the bioavailability of the drug. So, example for this cosmetic application includes cold cream, vanishing cream, etc. Next is the application, food industry application. In food industry, the emulsion is many food products are natural emulsions. Many food products are the natural emulsion, as this emulsion improves the taste, consistency, and shelf life. It improves the taste, consistency, and shelf life of the food products. For example, milk is as a oil and water emulsion, butter, mayonnaise, salad dressing. These are some of the food products which is in emulsion type. So, emulsion is not only in the pharmaceutical side or cosmetic side, it also plays an important role in the food industries also. Next is industrial applications. In industrial applications, like paints for preparation of paints, mainly it is used in emulsion paints for smooth coatings. This emulsion paint is used for the smooth coating. It imparts a smooth coating and it serves as the lubricants and cutting fluids in machinery. In industry side, some of the machineries will stuck in the halfway, so it acts as a serve as a lubricants in order to in order to improve the working life of machineries or in order to reduce the frictions. And next is mainly it is used in the latex. Mainly the latex emulsion is used in the polymer and the rubber manufacturing. Polymer and rubber manufacturing means it is an industry in which mainly it involves the um, rubber and polymer manufacturing. And it also helps in improving the efficiency and durability. In industry side, the emulsion helps to increases the efficiency and durability. Actually, I said already, it serves as the lubricant. So, thus, if it is serving as the lubricants, we can easily know that it enhances the durability of the machineries. And efficiency means also it increases the efficiency also in the polymer and rubber manufacturing industries. Next is agricultural applications. Agricultural application means it is used in the preparation of pesticides, herbicides, and insecticides, and it also ensures the uniform distribution of active ingredients, and it also improves the effectiveness of crop protection chemicals. So it improves the effectiveness of the chemicals which is used for the crop protection, and it ensures the preparation of herbicides, pesticides, and insecticides. And the last one is medical and therapeutic uses. It is used in the intravenous lipid emulsion for nutrition, and it is employed in the drug delivery systems like nano emulsions, and it provides controlled and targeted drug release. It provides controlled and targeted drug release. For example, we are using propofol as an anesthetic emulsions. So, in this picture itself, we can easily see that emulsion is used in the cosmetic side, food industry like preparation of creams, mayonnaise, butter, and it is used to mask the bitter taste of the cod liver oils. In this picture itself indicates the various applications of emulsions. Here also it is used as a grease so that it enhances the durability of the machineries in industrial applications. Pigments and paints which is used in the cosmetics as well as the industrial sites. Detergents, it is used as a used in the preparation of detergents which is used in our day-to-day life. Inks, medicines, usually it is used to formulate the dosage forms in different types. So it is used to formulate the active ingredient into creams, lotions, etc. Next is cosmetic sites. It is used to prepare the cold cream, vanishing cream, sunscreens, moisturizers, etc. Next, it also acts as a fuel. That was it increases the efficiency of industrial products. Next, food. Or nutritions. Many of the nutritions are getting from in the part of emulsions. For example, milk, butter, cheese, etc. are a part of these emulsions. So these are some of the applications. Let's recall it first: medical and therapeutic uses, cosmetic uses, in the cosmetic side, industrial application, then therapeutic uses, Next, agricultural sites. So these are some of the applications of emulsions which we are facing or which we are using in our day-to-day life. So emulsion is playing a very important role in our day-to-day life. Okay, students, I hope we all have learned something very interesting about the emulsions. Mainly, we have focused on identification test for the emulsions and the preparation method of emulsion along with the applications of emulsions. So first, we have learned about preparation of emulsions. In that we have studied about the dry gum method, wet gum method, half bottles method and in situ soap method. Next, in the identification test we have learned about conductivity test, dye test, dilution test, fluorescence test, cobalt chloride test, which is used to identify whether the emulsion is oil in water type or water in oil type. Next, along with side, we have studied the various roles of emulsion in various industries. So, okay, students, I hope we all have learned about the topics very clearly. Next, we will see in the next video. Thank you.